The 777 airplane is powered by two Rolls-Royce Trent 800 series engines. Each engine is rated at 74,600 pounds of takeoff thrust. The engines are three-rotor axial flow turbofans of high compression and high bypass ratio. The N1 rotor consists of a fan and a low-pressure turbine section. The N2 rotor consists of an intermediate pressure compressor section and an intermediate pressure turbine section. The N3 rotor consists of a high-pressure compressor section and a high-pressure turbine section. The N1, N2, and N3 rotors are mechanically independent. A bleed air-powered starter motor drives the N3 rotor during engine start. The N3 rotor drives the engine accessory gearbox. Each engine is equipped with a hydraulically actuated fan air thrust reverser. Next, we'll discuss the engine indications. Engine indications such as EPR, N1, and EGT are displayed full-time on ICAS. Indications such as oil temperature and oil pressure may be displayed on any selected multifunction display, but are normally displayed on the lower center MFD. EPR, N1, and EGT are primary engine indications. Digital readouts are displayed inside the boxes. Moving lines indicate relative value. The white dials indicate the normal operating range. Caution ranges are displayed in amber. Maximum operating limits are shown in red. Engine power is set by EPR. The reference EPR indication is displayed digitally in green above the box. Its corresponding reference target is displayed with this symbol. An amber line represents the maximum EPR available for the current conditions. A white line outside the dial indicates commanded EPR. Now advance the thrust levers and observe the EPR indications as the thrust changes. A white commanded EPR sector appears to indicate the momentary difference between commanded EPR and actual EPR. Retard the thrust levers to idle and observe the display. The N1 indicators display RPM in percent. The N1 operating limit is represented with a red line. If the limit is exceeded, the digital readout, box, and dial turn red. When the value falls below the limit, the box remains red until canceled by the crew. Cancel the exceedance indication by pushing the Cancel Recall switch. The exceedance indication is stored in memory and may be recalled by pushing the Cancel Recall switch again. EGT is displayed in degrees Celsius. The red line indicates the maximum temperature limit. Exceedance indications are similar to the N1 indicator. An amber band represents the maximum continuous EGT limit. The digital readout, box, and dial turn amber if EGT enters the amber band. However, during takeoff and go-around, the amber band exceedance indications are inhibited for 5 minutes after EGT enters the amber band. Now, display the secondary engine indications on the lower center MFD. Secondary indications include N2 and N3, fuel flow, oil pressure, temperature and quantity, and engine vibration. N3 is the only round dial on the secondary display and is similar to the N1 indicator. The remaining indicators on the secondary display use digital readouts inside boxes. Some indicators have moving pointers marking relative value along a normal indication range. Fuel, oil, and vibration indications are presented in detail in other engine lessons. Now remove the secondary engine indications from the lower center MFD. The secondary indications have been removed. If there is an exceedance of a secondary engine parameter, the secondary engine indications display automatically. In this case, the secondary engine indications cannot be cleared until the exceedance clears. If the secondary engine indications are displayed due to an exceedance and the lower MFD fails, ICAS automatically switches to a compacted display format. In the compact format, only the EPR and N1 indicators retain their normal display format. The other engine indications are displayed only by digital readouts. If an amber or red line exceedance occurs for any of the compacted parameters, the indication changes color to amber or red. A box for an EGT, N2, or N3 exceedance. The exceedance has cleared. Remove the secondary engine indications. The ICAS display has returned to the normal display format. Display the fuel synoptic. If a secondary engine exceedance occurs when the lower center MFD is displaying another format, the compact mode displays automatically. Next, we'll look at the engine EECs. Each engine is monitored and controlled by a dual-channel electronic engine controller, or EEC. The EECs receive input from the thrust levers to control the engines. The thrust levers are positioned manually by the flight crew, or automatically by the auto-throttle system. The thrust management function of AIMS calculates the reference thrust indications. The reference thrust is based on existing ambient conditions and the particular thrust reference mode selected by the pilot on the CDU. The thrust reference modes are selected on the thrust limit page of the CDU. These thrust reference modes are available on the 777. Touch each mode to see its definition. The controls for the EECs are located here on the overhead panel. This is how the panel appears during pre-flight and during normal operations. Both EEC mode switches are guarded in the normal position. EEC maintenance switches are located on the overhead maintenance panel. These switches provide ground test power to the EECs. Guards should be checked closed during pre-flight. The EECs have two modes of operation, normal and alternate. In the normal mode, the EECs use EPR as their primary thrust setting parameter. Thrust is set based on thrust lever position. The EEC commands the fuel metering unit to adjust fuel flow until actual EPR equals commanded EPR. The maximum allowable thrust available from the engine is continuously calculated and displayed by an amber line. Although maximum EPR varies with ambient conditions, the EEC normalizes the display so that the limit always displays at the top of the dial. Notice in this example that the actual EPR in both conditions is the same. Maximum rated thrust is always available in any phase of flight by positioning the thrust levers to the full forward position. At the full forward position, thrust limit protection allows full rated thrust without exceeding the maximum thrust limit. The EECs also provide N1, N2, and N3 RPM overspeed protection. Two different idle modes are available and automatically selected by the EEC: minimum idle and approach idle. Minimum idle is a lower thrust than approach idle. It is selected for most phases of flight and for ground operations. Approach idle is a higher thrust and therefore decreases acceleration time for go-around. Approach idle is automatically selected in flight when the flaps are commanded to the landing position. Approach idle is also selected when engine anti-ice is on. Next, we'll discuss the alternate mode of the EECs. The EEC alternate mode can be manually or automatically selected. If there is a fault in the EEC, the EEC automatically switches to the alternate mode. The EEC alternate light illuminates. When the alternate mode is selected automatically, it is referred to as the soft alternate mode because the switch is still in the normal position. Selecting the mode manually is referred to as the hard alternate mode. The autothrottle remains engaged whenever a reversion to the alternate mode occurs. This is true whether the alternate mode is engaged automatically or manually. The ICAS advisory message, Engine EEC mode, appears when the alternate mode is engaged either manually or automatically. The EPR indicator is always blanked when the alternate mode is engaged. In the alternate mode, the primary thrust controlling parameter is N1 RPM. In the soft alternate mode, there is no thrust reference on either the EPR or the N1 indicators. To obtain a thrust reference indication, the EEC must be put into the hard alternate mode by pushing the EEC mode switch. Before engaging the hard alternate mode, the thrust should be reduced. There is no thrust limit protection in the hard alternate mode. Maximum thrust in the hard alternate mode is reached at a thrust lever position less than full forward. If the thrust levers are at or near full forward when alternate mode is manually selected, the engines could exceed their thrust limit. Reduce the thrust on both engines. Now, push the right EEC mode switch. The right engine EEC is now in the hard alternate mode. The norm indication is blank. The right engine is now using N1 as its thrust controlling parameter and thrust reference. The left engine is still using EPR. To eliminate asymmetrical thrust or stagger in the thrust levers, place the left EEC in the hard alternate mode. Both engines are now using ENG1 RPM as their primary thrust reference. In the hard alternate mode, a command sector appears on the N1 indicator when the thrust levers move. An amber line on the N1 indicator represents the maximum thrust available. For review, here are the different features of each EEC mode. Let's look at some non-normal situations. Alternate mode has been manually selected on both EECs. Now, observe what happens when the thrust levers are advanced. The ICAS caution message, engine limit protection displays if the thrust levers are positioned to command an N1 that exceeds the maximum rated thrust. Retard the thrust levers. The ICAS advisory message, Engine RPM Limited, appears for the associated engine anytime engine thrust is being limited by N1, N2, or N3 rotor speeds. The EEC automatically commands the engine to keep rotor speed from exceeding the operating limit. In this situation, advancing the thrust levers will not increase thrust. The ICAS advisory message, Engine Idle Disagree, appears if one engine is using approach idle and the other is using minimum idle. Several other ICAS messages alert you to a non-normal condition. If an engine fails during takeoff,
engine fail.
ICAS alerts you with a time-critical warning.